All right, so let's do some advanced examples of identities. So here we have this one that shows almost like a compound angle here. And then here we have singular angles. Okay, so if we look at this, usually it's easier to simplify from this side going that side, because you're saying I'm going to reduce 3 theta to theta. That should be the idea, right? So you need to remember we had a couple of identities that we looked at. So we looked at sum identities, we looked at product to sum to product, basic identities, inverse, and all that. So now you have to be able to use all of them in combination. So you just see the patterns, right? So here now we're going to look at sine 3 theta and then try to reduce it to theta. So the first thing I'll look at is I'll imagine a sum identity there. So I'll come sine, then I'll start from 2 theta plus theta. I can't just reduce it straight, because then it would be theta plus theta, which doesn't really exist. Okay, so here now we're going to divide with sine theta, okay, cos theta. So we're reducing from left-hand side, okay, so left-hand side. Right, so now here we're going to expand this. Remember of our identity, spend time with that. So it's 2 theta cos theta plus, and this we said is going to be plus. So we start with cos 2 theta, okay, and then sine theta, right? We maintain our denominator here. So it's sine theta cos theta. When it comes to these ones, I think it's better to simplify as soon as, okay, you have a chance. So here I can already see that I can simplify by dividing both sides with my denominator. So I just go ahead and say sine 2 theta cos 2 theta over sine theta cos theta. Then here I maintain my sine, my operator there. Then here it will be 2 theta cos 2 theta sine theta over sine theta cos theta, right? So now here I can already see what I can simplify, okay? Now what is it that I can simplify already? It's the cosine, right? Okay, we'll ignore the mistake I made here. It was sine 2 theta cos theta. Remember the way they change. So here I'm going to cancel these two, right? Then here I've got a chance to cancel these two and simplify it. So I can simplify this further by saying that this is now sine 2 theta over sine theta, then plus this I maintain, it will be cos 2 theta over cos theta, right? So we still have a chance to expand. So let's expand this side and that side. So here we can say that, remember this sine 2 theta was giving us 2 sine theta cos theta. So 2 sine theta cos theta, right? Then we have sine theta here, right? Then we are going to say here, now here we have two identities. Remember there was cos 2 theta is equal to 2 cos squared theta minus 1. Then another one that you could actually translate to 1 minus 2 sine squared theta, 1 minus 2 sine squared theta, right? So now if we have those two, what are we going to do? We are going to choose one that seems us closer to our answer. Now, if you see here, you see that this is cosine and this is a, this originates from cosine as well. So it's very, very likely that if we choose the one for cosine here, it will send us closer to the answer, right? So 2 cos squared theta minus 1 over cos theta, right? So now we know that we have reached a point where we are getting closer to our solution. So what else can we do here? I think we can cancel sine and sine. So we'll have 2 cos theta now. Now we've reduced the first one, which is this side, to theta, okay? And then that's our strategy. Then we can say plus. Here again, we're going to do the same thing, simplify here, right? So now if we simplify it here by dividing, we are going to have 2 cos squared theta over cos theta, then minus 1 over cos theta. Remember, this is cos theta, not cos squared theta. So I can cancel this with that square, and then we'll have 2 cos theta plus 2 cos theta, then minus this is an inverse of sec theta, right? So we have that. Now these are like terms. In our algebra, we said we add like terms, so nothing is different here. Everything is the same. Coefficients can be different, but we see that the function and the angle are the same, so we can add these. So these are going to be 4 cos theta. Then here we're going to maintain our sec theta. Right. So if we look at this, it's exactly the same as this. Hence, shown. Okay. All right. So let's go to another example. This is our second advanced example. It looks very complicated, but it's actually very simple. So I'd like you to pause this video and give it a go. Right. Okay. So now we proceed here. We look at two things. Okay. It's either we try to reduce this angle to x. Okay, but it looks very complicated if you look at this side. How do I get 2x to have these two and then also to square it? So it looks like a mountain to climb here. So the best is look at where there's more activity. You have more chance to find more channels to get to your answer. So here I'm going to use my left-hand side because I'm envisioning more activity here than this side. Right, so what's the first thing that I do? These are not like terms, so there's nothing I can do inside the brackets. So I have to expand this. Now expansion, remember, it's just the same as the normal algebra. So we're going to split this and then multiply with the remaining factor. Okay, so we'll have sin x plus cos x, right? Then I have, remember, I'll split the one of the factors. Then I'll have cos x, right? Then sin x plus cos x, like that. So I'm going to expand this. This is going to be sine squared x, right? Plus sine x, this and that, cos x, right? Then I go to this one here. This one will be cos x and then sine x, right? Then this is going to be plus cos squared x. Okay, so now I can collect any like terms that I have and add them. There's just addition here. Okay, so the only ones which are like these ones, these two, they're multiplying the same thing, so they're same things. It's like I'm saying 2 times 3 and the other one is saying 3 times 2. It's the same thing, right? So here we have a chance to add, so I'll do sine squared x. I'm not doing anything with this, so I can bring it this side, cos squared x. Then these two I can add them, then I get 2 sine x cos x. Now you remember our basic identities. That's why it's very important to remember the patterns. So this is, we say that this plus that gives us a 1, right? So this is 1. And then this one, we remember from our double angles, this one gives us sine 2 theta or sine 2x, right? And then we get our addition there. So now our final answer is going to be 1 plus sine 2x. Looked very complicated, but it's actually very easy. You'll see that this is 1 plus sine 2x, and then this is 1 plus sine 2x. Okay, let's look at another example. Okay, so here they've asked us to prove that this side and that side are the same. Okay, this is quite deceiving because usually you'd think that there's more on the right hand side than left, so you'd prefer to go from right to left. But this is very deceiving because remember, this is actually more content here than there. Why? Because you know that you can actually simplify these two, cosine and sine, and then also you can expand the alpha plus beta aspect, right? So how do we start this? The easiest is to go from left to right, okay? So we can left-hand side to right-hand side. That'll be our proof, right? So I'll say tan alpha plus beta, right, is equal to what? Is equal to, in fact, let me create more space, right? So let me create more space. I'll say tan alpha plus beta, right, is equal to this. I can actually split this and say it's going to be sine alpha plus beta, okay? And then it will be divided by cos alpha plus beta. Remember earlier we had said that tan theta is equal to sine theta over cos theta. So here theta is just a alpha plus beta, okay? So now we remember the sum and difference identities. So we are going to expand this carefully. So this is going to be sine alpha cos beta. And then we said that it starts with cos here to maintain the angles. So here we're going to say alpha, then sine is going to be beta. So sine, these are different, okay? These are different. And then we go to cos. Cos, we say that it will maintain the same functions on the same side. So here we have cos alpha, and then it will maintain cos beta, okay? Then here we said it's subtraction instead. Then we're going to have sine alpha and sine beta. That's the difference. That is the next thing that we can do. Okay? The next thing is where the secret is. We're going to divide the terms by this. Because why did we choose that? We're looking for a 1 here. And so I can already create that 1 here and see what it does. But if I'm dividing with the 1 here, I have to maintain the integrity of the whole equation. By what? I divide the thing on top and the thing at the bottom. So I'll do this. Okay, here's another example that I got from examsolutions.com.net. Okay, so now here we need to look at which side is actually having more activity, like we said already. Okay, I can come from here to there, but then it's a little bit more complex because I know that tan theta over 2 gives me the identity of 1 minus cos theta over 1 plus cos theta. And it doesn't look like I can actually easily get to there, okay, using that. But I think I can work around this and bring it to this side, right? So what do I do here? I start off by trying to simplify this into a known form of this one, right? So I just copy this sine theta over 1 plus cos theta, right? Now, when it's at this stage, what can I do, right? So I remember that I can use two identities here. Here I can use the Pythagorean, and here I can maintain that, but then just do a small trick to do something. So here I'll use the Pythagorean. So this is sine squared theta plus cos squared theta is equal to 1. So meaning that I can actually say sine squared theta is equal to 1 minus cos squared theta, right? Then I can find square roots of this, then this goes, then this is plus or minus. But we're going to ignore this just to keep our work a little bit cleaner, right? So here we can see that it's a square root of that, so we'll go ahead and put the square root of cos squared theta here. And then we continue to divide with what we're dividing with at the beginning. So this is cos theta, 1 plus cos theta, right? Now, what else can I do here, right? What else can I do here? What else I can do here is I can try to combine these two. But how do I combine them? I can only combine these if this and that have got the same radical. So for example, if I'm dividing root 3 over root 2, okay, I can't easily combine that. Or if there's no root and then I'm trying to divide, I can't easily do that. So I have to create a similar radical here. So I can create that by saying 1 minus cos squared theta. Then I can divide this. It's like I've got 2, right? This I can also create it to be that by simply saying that this is root 2 squared. So it's the same 2, okay? I can still get it back to here. Right, so here I will say that I'll square this. Okay, I'll square it, but I'll put it under a radical, meaning that this can still come back to this one. So I've maintained my integrity, right? And then I look at this, okay? So I can combine these two now, right? So I can combine these two. I will have something like 1 minus cos squared theta. And then here I'll have 1 plus cos theta squared. Okay, so I've made that combination now. Now we've managed to get to a place where things can begin to appear like they're simplifying, right? So we have this now. We have that. So what else can we do? I can see that this is a difference of 2 squares. So I'll do a square root here. And then I'll say 1 minus cos theta, like that. Then I'll do 1 plus cos theta, like that. Then I'll do division. Then this, I'll expand it, cos theta. And then I'll expand this side, 1 plus cos theta, like that. Right. Then I can see that this and that are actually taking care of each other. Then here we're going to say, we can still say plus or minus, remember, I'm just trying to simplify my work here. So here I'll have 1 minus cos theta. Then here I'll have 1 plus cos theta. Okay, so you remember that this, okay, you remember that this is actually, you can remember that this is actually an identity for tan theta over 2. Okay, so we would have proved that this side is the same as that side, because you've recognized now that this is tan alpha over 2, tan theta over 2. Where possible, I like to use the basic identities like I used in the previous example, but you can still use other identities to still solve this one. Okay, so we'll still come from left-hand side to the right-hand side. And so this method is the one that the guys at examsolutions.net used. I'll just explain it here. Okay, so remember this now, you treat this as a double angle. All right, so that one becomes 2 sine theta over 2 cos theta over 2. And remember, here we maintain, but here again, okay, we use, remember we're going to turn. So we need a cosine somewhere. So it will be at the bottom here. So we'll say 2 cos squared theta minus 1, right? So I'll cancel these two. Then this becomes 2 sine theta over 2 cos theta over 2, right? Then I still divide with my 2 cos squared theta over 2, right? This is a half angle, okay? So here we're going to cancel that. Then I'll continue here and say sine theta over 2, then cos theta over 2. Here we've got the square, so we'll have cos theta over 2 cos theta over 2, right? So we're going to cancel this and cancel that. Then what will be left is sine theta over 2 sine theta over 2, cos theta over 2, rather. Cos theta over 2. Remember, we got cos here, okay? That was just a typo. So here now we know that this is same as sine theta over cos theta, and this gives you tan theta over 2. So this is another method. I usually prefer to use basic identities where I can, because when they get a little bit complicated like this, it's very difficult. It's very easy for you to miss out on something. But if they're basic identities, it's easier to visualize them. Okay, but this is okay. You can use this method as well. All right. Right. Allow me to be a broken record and repeat this. So in conclusion, so the identities are very important. If you have to do your calculus, if you have to do solving problems in trigonometry, you have to have an idea of a good hold of identities. Okay, so the main way that I think one may be able to capture the patterns and see them when they are hidden is to know all the basic identities. Okay, these could be tangent, could be inverse, Pythagorean, could be even or old identities. We've got to be able to see those. Then from these basic ones, we see that they gave us the sum or difference ones. The sum or difference ones are the ones we had, like a plus b gives you something. Then from this, we saw that we can actually build the product to sum, okay? And then we can also build the sum to product. These were very important identities. You saw how we were using them now to prove our identities. And then from here again, we're able to form the double angles and the half angle identities. Once you know these, which is 1, you know 2, you know 3, 4 in that order, you know 5, then you know 6 in that order, you will be able to see a lot of patterns, and you'll be able to solve a wider variety of problems. Okay, so I wish you all the best as you study, as you learn these topics. Please subscribe to the channel, share the material. It's free for everybody. All the best.